Chapter 10, Exercise 5 is asking you what is meant by the term reversible reaction. And so we're used to seeing a reaction where you can take one thing, one molecule, and add another one, and then a kaboom happens, and something could happen like, for example, the two can stick together. So you'll have those two, but they'll be together. And so that was part of the reaction. In this chapter, though, starting with chapter 9, actually, you're thinking about reactions happening in water, in solutions. And when that happens, the products that you make in these sort of reactions, these products, are still bouncing around in whatever watery container or solution that they're in. And sometimes they bounce around, knock around, vibrate, hit into stuff, get smacked in the face with other molecules hard enough that they come apart again. And so at any given second, molecules are coming together in what could be described as a forward reaction, and coming apart in what could be described as a reverse reaction. A reaction in which both a forward reaction and a reverse reaction are happening at the same time is called a reversible reaction. So a reversible reaction is a reaction in which the forward reaction and the reverse reaction are happening at the same time. A nice analogy for that is given by a little water tank that you can see in this sort of H diagram here. In a water tank, the water looks like it's not doing anything, but actually the water on the left side is flowing to the right. And you know because if you put dye on the left side, like say you were to put a drop of purple dye, it would eventually spread through the whole thing. And it only does that because the water on the left is going toward the right. At the same time, though, the water on the right is moving to the left. And you know because you can do the same sort of experiment. Put a drop of dye on the right side, and it'll gradually spread out through the whole thing. So both the water on the left is both going to the right side, and the water on the right side is going to the left side at the same time. And so you can sort of use that as an analogy for how to think about these reactions, where the reactants are going to the right and the products are going to the left at the same time in these reversible reactions that are very common in watery solutions, because the products don't just dissipate into the air, spread apart, but they're stuck in whatever watery solution you're into so that they can knock apart again to get the reactants. So these are a common problem type, or these are a common reaction type in watery solutions.